everyone, and welcome to my talk. First of all, I would like to apologize for not being here in person. I had the last minute issue, but I didn't want to give up on the opportunity to be part of this great event, and so I would like to thank the organizers of stackconf. Um, so imagine your family is going on trip to Paris, and they're kind of in a rush. They're packing their suitcase, they're rushing to the airport, and in the plane, they actually notice that they forgot something very valuable. You know what I mean? They forgot you. And if the story seems familiar to you, it's that's because they actually made a movie about it. Home Alone, exactly. Um, and so if you're wondering why I'm telling this story, try to imagine how little Kevin in the house is going to spend Christmas knowing that burglars want to come and break into his house. So he needs to find the best way in a very limited amount of time and money, because he doesn't have any, to secure his house. And so he's trying to come up with some idea of how to um, prevent people from entering into his house. He doesn't have time, so he's thinking about the minimum, but with high efficiency. That's why I'm calling minimum viable security. Now, is it minimum security? How can this be in the same sentence? Well, this is exactly the topic of my talk, and we'll come back to this in a second. I'm David Melamed. I'm the co-founder and the CTO at JIT, a continuous security platform for developers. JIT's mission is to help engineer organization to own the risk of the application they're building by providing a security plan as code that can be automated, so that we're packaging most of the popular security tools out there in order to help you secure your application. I'm a tech and automation addict, and if you want to reach out, you can follow me on Twitter or on LinkedIn. But let's get back to Kevin's house. These are the burglars, Marv and Harry, the wet bandits, right? So what Kevin does when he knows that he needs to protect his house? Basically, he's drawing a map of the house and has a battle plan ready. Now, in the battle plan, it's really important for him to exactly know how to map all the different entry points into his house with some booby traps that he's planning. And so, in the ground floor, he's preparing some surprises for the burglars. In the attic, he's also planning his escape in case they're actually entering into his house. Because at the end, the question is not whether or not you're being able to prevent attacks. It's going to happen at some point, and so you need to be prepared in case it happens, in order to plug the hole as soon as possible and detect it as soon as possible in order to protect your house. So how does that look if you're thinking about a real application, right? So the first thing we would like to do is to protect the perimeter of your application. So what are the different entry points if you have an application hosted in the cloud? Well, basically, you have multiple entry points. The first of them is your CI/CD pipeline, because basically, at some point, you're deploying from your GitHub, Bitbucket, GitLab. You will deploy your application. You can use GitHub Actions. You can use Jenkins. At some point, you have a pipeline, and you need to protect your pipeline because this is the first entry point into your application. The second is if you're looking at your public cloud provider, basically you have some public resources. Can be IPs, can be buckets. There's a lot of things that have external exposure. You need to make sure that you protect them. But your public cloud has also access to users, your own employees, developers, DevOps. They have access to your environment. So there also, you need to consider that you have some admin access, some user access. And finally, you have your third parties, all your SaaS vendors that have also access to your environment, and you also want to make sure this access is protected. So the way you can protect all these different entry points, for each of them there's different control. For your CI/CD pipeline, you need to make sure that you have least privilege, meaning that you don't want to grant the biggest access to your CI/CD pipeline. Make sure that you only grant access with the minimal role in order to deploy your application. If you need to create some resource in your cloud, let's go for it. But don't grant admin access to your pipeline. When you're thinking about your public resources, well, there are two types of controls that are really useful for that. You have the cloud misconfiguration tools, and you have some pen testing that also help with testing your application. When you're thinking about your users, the same thing apply. You want to make sure that you have list privilege and MFA to protect, to make sure that their user are protecting their own access. And finally, for the third parties, well, basically you have two types of controls. First of all, you want to make sure that your access to those third parties is protected using MFA. And the second, you want to make sure that the scope of their access to your environment is limited to basically what they need and not more than that. So these are a couple of examples of what Kevin used in order to trick the burglars. Now, when you think about your application inside your cloud, there's also a lot of different things you need to take care about. The first thing is the traffic. You want to make sure that the traffic is encrypted, protected. You have some secrets probably in your environment. You also want to make sure that they do not leak. Between the different services, if you're using a microservice, you want to make sure that also the access is limited to what you need. In terms of your code, you also have probably dependencies, libraries. How can you make sure that they're not vulnerable? And finally, there are two type of risks that are a little bit overlooked sometimes. One is instant investigation. Again, the question is not whether or not you will be attacked, is when. And so you need to put in place enough logs in order to make sure that you will be able to investigate what happens. And finally, something terrible happens and you have some data loss, you want to make sure that you have disaster recovery. So the type of controls you can use for all of them, all of those risks, are basically encryption, making sure your traffic is encrypted, using some type of secret manager in order to store all the different secrets, ensure least privilege. That's for your service-to-service communication. You want to use login both in terms of your application and in terms of your infrastructure in order to make sure that you can review incidents and detect anomalies. You want to have dependency check for your libraries so that you can ensure that there's no vulnerability, or at least you know about them and you can fix that. And finally, for your disaster recovery, you want to make sure you have backup of your data that is working. So you need to ensure and test it. Great. These are also the type of booby traps that Kevin used inside his house once the burglar were in. Now, if you think of minimum viable security, basically what does it mean is that you need to have in place the minimum type of controls in order to ensure that your application is secure, so that you won't be embarrassed in front of your users. So this is an example, and we can discuss all of these controls, but basically this is an example of what I believe is the minimum viable security for an app that is stored in Kubernetes. Basically, as I said, you have your pipelines, you have you want to make sure that you have dependency check there, you have your cloud, and you want to make sure that your different entry points into your house are protected using different controls that I just mentioned. And inside your application itself, you also want to make sure that you have the basic controls in order to protect your application. Now, what about building some small microservice in order to demonstrate some of those controls in practice and how easy it is to actually integrate a lot of them within a few minutes, right? So in order to do that, I will use a Python-based application. So you can consider that it's a simple, very simple microservice. It's based on a fast API, so web framework that I will use, and the app, it will display some movies information. In order to save some time, I will use a very, very simple database, data persistency, called SQLite, and I will store my code on GitHub. I will use GitHub Action as a CI pipeline. And my goal here will be to demonstrate how it's easy to integrate 7 different tools that are part of the MVS that I just showed previously. And here, all of them will be integrated in the CI pipeline. Now, everything that I will show you now, basically there is a public repository that you can find here, the address, so that you can play with it, fork it, you know, raise some issues, whatever it's used. Okay, so let's get started. Basically, let's review the different type of things we want to do here. First of all, we want to protect our code. And so if you're thinking about code vulnerabilities, one of the best control around is SAST, Static Code Analysis. It's one of the oldest. It's based on detecting some vulnerabilities based on existing patterns. And for that, we'll use Bandit, which is a very popular open source tool in order to check for static code analysis. It has about 35 rules that are built in. The second type of control we use is for secrets. So we want to detect secrets here. And for that, we'll use another open source tool called Gitlix from Zachary Rice. And it's basically searching for well-known secret patterns like GitHub personal token or Slack token, AWS keys, and even has some generic regex for every type of secrets, basically based on entropy. Also, it has the major advantage of looking through the whole Git history, so that even if you remove a secret from GitHub but still leaves that in the history, it will be detected. The next control we'll use is for vulnerable dependencies, and for that we'll use the OWASP dependency check projects, which basically looks for all your libraries for any public disclosed vulnerabilities based on the NVD database. Next, we'll have some infrastructure, so some Terraform code. And here we will use Kix, which is an open source tool developed by Checkmarks in order to check for different types of misconfiguration in your infrastructure as code. It supports a lot of different languages, but here we'll use it for Terraform. Next, we'll use, we want to also make sure that our application is secure in terms of runtime. And so we'll use the OWASP ZAP open source tool that has a lot of different built-in rules and will run through our public endpoints. Specifically here in this demo, I'll use the API version of it, which will scan the application based on OpenAPI, so basically on Swagger, that defines the list of all the endpoints that are provided by the API of the application. Next, there will be also some container, because I want to build and encapsulate my application as a container, and this is the way it runs in Kubernetes. And so for that, I will use Trivy, which is an open source tool developed by Aqua, in order to check both for issues in the Docker file and in the image itself once it's built. And finally, I want also to make sure that my GitHub organization is protected using MFA. And so for that, I actually built myself a very simple control, a few lines of code that will make sure that I don't have any users in my GitHub application, in my GitHub environment that don't have MFA enabled. Okay, so if I sum everything up, basically these are the different controls that I will use: bandit, gitleaks, kicks, OS dependency check, trivy, OS zap, and the custom one that I built. All right, so let's go into some code now. So this is the application that I built. Um, and as you can see here, this is the main file. These are the different endpoints that my API is providing. There is the slash movies to get the list of all the movies, slash movies counts. The slash movies actually also provides a way for me to check for a specific movie in the database. I can get some information about the movie itself, slash movie idea, and at the end, I can also get the list of all the stores in this movie. Okay, this is the very, very simple Python application. Let's see that in practice. So this is the slash movie. Let's check for a specific application, for a specific movie. This is Titanic. Okay, and if I now want to get the list of stores in this movie, this is basically what I can do. I get the list of stores. Now it's very simple application, as I said. Let's go back to the code. As you can see here, you can spot directly that there can be some SQL injection, but let's get back to it once we will run the different tools. What do I have in this project also? So the movies DB is my database for movies. I have some requirements here, and you will see that this one is actually a vulnerable old libraries. I have a Docker file with some secrets here that will hopefully will be detected by my tools. What do I have here? I have some Terraform file. Okay, the Terraform is basically creating the bucket and some DynamoDB table. Here also I could write it in a more secure way. But what I want to actually go through with you is the security.yaml, which is the GitHub workflow that I will use, because here lies all the magic. Let's go one by one of all the different jobs that are running here. So basically, the SAST run, the SAST job is using the Bandit SAST tool, and as you can see here, I'm using directly a GitHub action that is providing the encapsulated version of Bandit within GitHub action. I'm only specifying here where I want it to be outputted, the results, and the format of the results. And I'm uploading at the end the artifact as in GitHub itself. The second job is secret detection. I'm using gitleaks. Also is providing its own GitHub action, so I'm using it directly here. Dast, which is Zap, the web application. Here, what I'm doing is basically leveraging the fact that Fast API is providing an endpoint, an open API endpoint for all the different endpoints of the API. And so here I'm basically running Zap here with its API scan action that is providing by Zap itself. And what I've done before is build the service, build the application as a container so that it can run as a service of GitHub Actions, so that I can point to it and check the different endpoints of the API and make sure that the container runs before I run Zap here. I'm using some health check using this slash movie slash count, making sure that it returns some proper response. So this is for test. Infrastructure, I'm using GitHub Action provided by checkmarks for kicks, and I'm saving here. I'm putting the results in the console. Next, for SCA dependency check, what I'm doing is basically also using the GitHub action that is providing by dependency check itself, configuring it so that it will fail only on CVSS that is more than the 7L plus, which is the score and the severity of the vulnerability. And I'm enabling the experimental mode because Python requires that. That's support for Python. And at the end, I'm uploading the results in GitHub itself as an artifact. Next, I want to check my container. And so basically here, I'm building the container directly in this step. And after that, I'm running a Trivy against this built container image. And I want only to filter for critical and high in terms of vulnerabilities. And finally here for MFA, well, here as I told, I built myself the control. It's basically a few lines of JavaScript that are embedded directly here. And what it does is go through all the list of the members and filtering the one that don't have MFA. And I'm only outputting that as a console log into the log because I want to see if I have some users that don't have MFA enabled. Okay, so if that was fast, actually, you'll have all the code so you can review everything and test it by yourself. Let's see how does it look like on GitHub itself. So this is the repo that I talked about, and it's a public one, so you can play with it as much as you like. Let's go for a pull request that I opened previously. And as you can see here, these are all the checks that I just reviewed with you, and everything is failing. So basically, that's a terrible application. Now, if I want to see the details, let's take a look at it. So first of all, let's go with the SAST. SAST is actually providing the output as an output JSON in the file. And so I'll be able to review that once I download the artifact. The secret scanner is here. It's actually telling me that I have a secret. Here it's redacted. It's in the Docker file, so that's good that it was detected correctly. The API scanner. So there are a lot of issues. Actually, for Zap, Zap is also providing that as an issue in the scan report. I can review it here. I can see that there are different issues here in my API. If I'm going back here, let's try to take a look at Kix. Kix also finds some issues. These are actually all the issues that are found. You can see everything in the log. Dependency check also finds some issue in the requirements.txt. These are all the CVEs that were detected. Container scanning. Let's take a look at Trivy. As you can see here, also in the log, you have the list of all the CVEs that were detected in the image that I used. And finally, for MFA, I can see that this specific user doesn't have MFA enabled. Now, on top of that, what I can see if I'm going to the actions here at the bottom, I can see a few annotations because some of the controls are also providing annotations directly. Here, for example, I can see that Zap provided some, that Kix provided some. These are actually issues that Kix found, and everything here is laid out in the log. These are all the artifacts that can review with all the different results, and GitLeaks also has some kind of summary that he's posting here as a job summary here in the log. So what's nice here is that I could see that all the different consoles are working just fine. They found a lot of issues. But the drawback here is that everything is talking in a different language, and basically all the format is different. I need to go either through annotations or look at the files themselves of the different artifacts, or look at the log. So that's not really the best way to consume all these different findings. And I'll get back to that in a few seconds. But what I wanted to briefly summarize, because I'm getting near the end of the time, is that in terms of minimum viable security, there are 8 different areas that you should look at. First of all, in your code, you have some vulnerabilities, you have secrets that you take care of, making sure that you have logs enabled to review incidents and check your vulnerable libraries. In terms of infra, you need to check some for misconfiguration using some cloth misconfiguration tool, and you also want to ensure that you have least privilege remote access. For your runtime, you need to do some pen testing and check your API for security issues. In your pipeline, make sure you don't have any vulnerable containers. So while you're building your containers, also check for vulnerabilities, and that your pipeline has least privilege access to your cloud infrastructure. For your data, make sure that you have data encryption at rest, and all your secrets are stored in a proper secret storage. For your third parties, make sure that you have MFA enabled everywhere and that your access is secure. I didn't talk too much about it, but one of the most basic requirement for your people is that they use a password manager, right? No more exchanging passwords on Slack or on Notepad. Use a password manager. And finally, for your operations, you want to make sure that you have some basic audits and that you're backing up your data, and for that you need to test it. So I talked a few minutes ago about the fact that consuming all those different findings is not very easy while you're doing that in the log of GitHub. So what we did at JIT actually is improving this experience. And on one hand, you could really define and manage your whole security plan. So the list of all the capabilities that I showed here, this is something that you can manage directly in JIT. And also the way you consume all your issues, well, that's basically directly built in your PR as a security review. So the same thing that you're doing when you're reviewing your PR and looking for bugs, we did the same thing with our bot for security. And so you will be able to consume everything in the same language, in the same format, directly in your PR. So what I did here is merely mention you what is minimum viable security. But obviously, this is only the beginning of the journey. There are way more things that you need to do when you want to provide the best security around for your security. But that's probably something that I will touch upon when I will come back for another session at, next year, maybe to the same conference. If what I told you here is intriguing you, and you want to check for yourself what is minimum viable security, I encourage you to get into git.io and test our free beta. If what I told you is inspiring you and you want to also to help other developers and DevOps actually to secure their application, we're looking for people like you. And if you have any question, feel free to contact me at david@git.io. Once again, thank you very much for your attention, and see you soon.